Hi students, now let us have a look into the simplification of Boolean function using Karnaugh Map. We studied how to simplify a Boolean function using algebraic method. In that method, you should remember the postulates and basic theorems of Boolean algebra. And it is a very tedious process and awkward in the sense that it lacks specific rules to predict each succeeding step in the manipulating process. But this Karnaugh map is a straightforward procedure for minimizing the Boolean function. Karnaugh map is also called K-map. The Karnaugh map is developed by Veitch and later modified by Karnaugh. So this diagram is also called Veitch diagram or Karnaugh map or K-map. And it is the pictorial representation of the Boolean function or the truth table. So here each square represents a min term. That means the K-map is actually contains a number of squares and each square represents a min term. Two variable K-map means we have a function or a truth table with two variables. So we can draw the two variable K-map like this, which contains 4 squares. Because this two variable K-map has 4 input combination, 2 raised to 2, 4 input combinations. So the truth table contains 4 squares, and here there is the separation, and here we write the x and here we write the y, because x and y are the input variables. Okay, so this can be interchangeable, no problem. So x can have values 0 or 1. Similarly, y can have values 0 or 1. Okay, so this square represents 0, 0, and this square represents 0, 1. Here it is 1, 0, and here it is 1, 1. We take this order: 0, 0, xy 0, 0, xy 0, 1, xy 1, 0, xy 1, 1. Okay, so the decimal equivalent of the number 0, 0 is 0. So this actually represents m0. Okay, min term m0, 0, 1 is m1, and 1, 0 is m2, and 1, 1 is m3. So each square represents a min term m0, m1, m2, and m3. Okay, then the adjacent cells or the adjacent squares should differ in only one bit. So consider these two, m0 and m1. So the first bit is same and the second bit only different. These two are adjacent. m0 and m2 are adjacent. Here first bit is different and second one is same. And here also m1 and m3 are adjacent. That means first bit is different and second bit are same. Also these two are adjacent, m2 and m3 are adjacent. That means first bit is same and second bit is different. Okay, so the adjacent cells should differ in one bit only. Okay, next is 3 variable K-map. Suppose x, y, and z are the input variables. Okay, so here there are 3 input variables. So 2 raised to 3 is equal to 8 different input combination. That means 8 min terms are there. So we can draw the K-map like this. It should contain 8 squares representing the 8 different min terms. So here we have 2 rows, so it represents a single variable. A variable can have values only 0 and 1. Here we have 4 columns, that means 4 combinations. So here we can represent yz. So this is the horizontal representation of the 3 variable K-map. Same thing we can represent as a vertical combination also. Okay, also we can interchange these two values. That means here we can represent z and xy like that. Okay, no matter whatever the variable is written here, but you should take it in binary order. Okay, so here yz we have the values 0, 0 combination 0, 0, 0, 1. Here it is we written as 1, 1 and 1, 0, 4 combinations. why should I write 1 1 here and 1 0 here? Because the adjacent cells may differ in 1 bit only. So when you write 1 0 here, it differ in 2 bits. First bit is different and second bit is also different. That is not possible in K-map. But when you write 1 1 here, instead of 1 0 1 1 here, first bit is different and second bit is same. Okay, so here also first bit is same and the second bit is different, only difference in 1 bit. Okay, that is the specific rule for writing the or drawing this K-map. The adjacent cells may differ in 1 bit only. So this column, this square represents 0 0 0. This one is 0 0 1 and this square is 0 1 1 and this one is 0 1 0. Here it is 1 0 0 1 0 1 and here it is 1 1 1 and here it is 1 1 0. Okay, so this actually represents M0. This one is M1. 0 1 1 means 3, so that is M3. 0 1 0 means 2, that is M2. Here it is M4 and here it is M5. 1 1 1 means M7 and 1 1 0 means M6. So this is the order of writing the minterms in the squares. Okay, then next one is 4 variable K-map. In 4 variable K-map, we have 4 variables. Suppose the variables are W, X, Y and Z. Okay, so we can draw the K-map like this. Here we have 2 raised to 4 is equal to 16 different squares. Okay, so here it is the separation and here we write Wx here and Yz here. Okay, 2 variables, so here we have 4 combination 0 0 0 1. Here also we write it as 1 1 then 1 0 because the adjacent cells may differ in 1 bit only. So here it is 1 1 1 0. Okay, here also we have 4 columns. So Yz is the variable, so it has 4 combination, that is 0 0 0 1. Here also we write first 1 1 then 1 0. So this column represents 0 0 0 0. Here it is 0 0 0 1. Here it is 0 0 1 1. Then 0 0 1 0. 0 0 0 1 0 0 0 1 0 1 0 1 1 1 0 1 1 0. Here it is 1 1 0 0 1 1 0 1 1 1 1 1 1 1 1 0 and here it is 1 0 0 0 1 0 0 1 1 0 1 1 and 1 0 1 0. Okay, so 0 0 0 0 means here it is M0, this one is M1, this one is M3, here it is M2 and M4, M5, 1 1 1 means M7, M6, 1 1 0 0, 1 1 0 is 0 0 is actually M12, here it is M13, here it is M15, M14, then here M8, M9, M11 and M10. So this is the structure of the 4 variable K-map. Okay, so 2 variable K-map, 3 variable K-map and 4 variable K-map. Suppose we have given a Boolean function or a truth table. We can use this K-map for simplifying an SOP expression. Okay, sum of product expression or sum of minterms. That means Boolean function can be expressed as sum of minterms. So that means, suppose you have given a truth table. In that truth table, we take the output column is equal to 1 and that minterm. Okay, sum of that minterms whose output column is equal to 1. For example, suppose we take the truth table of the OR operation. You know what is an OR operation? We can draw the truth table of the OR operation. It has 2 input variables and 1 output variable. Okay, so here x and y are the inputs and z is the output. So the combinations are 0 0 0 1 1 0 1 1. Output is equal to 1 only when one of the input is equal to 1. Then both inputs are 0, output is equal to 0. Okay, you know the expression for this OR operation is z is equal to actually x plus y. Okay, so we can draw the K-map for this OR operation. Okay, so here it is the x and y. So y can have value 0 1, x can have value 0 1. So this can be represented as sum of minterms. Okay, we take the minterms whose output value is equal to 1. So for the minterms m1, m2 and m3, output is equal to 1. So in the K-map, we marked those squares as 1. 0 1 1, 1 0 1, 1 1 1. Next step is grouping the ones. Okay, we can group them as pairs or quads in the case of 4 variable K-map. So here we can pair the adjacent squares. Here these 2 squares are adjacent, so we can pair them. Pair these 2. Okay, so these 2 cells are adjacent, so we can pair these 2 ones. Okay, so we get 2 pairs. The next is, when you pair 2 cells, actually one variable is cancelled. How it happens? See this. Here this column is equal to, this one means x bar, this one means x bar y, then this one means xy plus xy. Okay, here when we apply distributive law, that means y into x bar plus x. X bar plus x is equal to 1. So y into 1 is equal to y itself. That means when you pair these 2, actually one variable is cancelled. Okay, so that variable is, here x can have values 0 and 1. So it is cancelled. So we have only y itself. So that is the procedure for getting y. When you take these pairs, this pair, consider this pair, then here y can have values 0 and 1. So that is cancelled. So x can have value 1. So that means for this pair, the Boolean expression is x, and for this pair, Boolean expression is y. Then we take both pairs and OR the terms x plus y, because it is a sum of minterms. Clear? So we get the expression as x plus y. Okay, so in K-map, we write 1 for the minterms where output is equal to 1 in the truth table or the given Boolean function, because Boolean function is a sum of minterms. Then grouping the ones. We can group ones as pairs, quads or octets. In the case of 2 variable K-map, we can group them as pairs or quads. Okay, when you pair the variables, pair the ones, then one literal is cancelled. So in the 2 variable K-map, when 1 literal is cancelled, we have only 1 variable, because it is a 2 variable K-map. Okay, in the case of a 4 variable K-map, we have 4 literals in a term. In term contains 4 literals. When you pair them, suppose when you pair these 2, Okay, so this z is different, so that is cancelled. So in the horizontal position we have only y, and in this position we have w bar x bar. So the representation is w bar x bar y. So from the four literals, this pair cancel one literal and we get an expression contains only 3 literals. Okay. Next, consider a Boolean function f is equal to x y bar z plus. Next, consider a Boolean function f is equal to x y bar z plus x bar yz plus x bar y z bar plus x y bar z bar. Okay, so this is a SOP form. Each term contains 3 literals and sum of the min terms. So it is an SOP form. So that means the Boolean function contains 3 variables. So we can draw the K map. K map with 8 squares, and here we write x and here it is yz. So x can have value 0 1, yz can have value 0 0 0 1, here it is 1 1 1 0. Okay, so this represents the min term 0, this represents min term 1, this is min term 3, 2, 4, 5, 7 and 6. Okay, so you can so it is easy for you to mark the min terms, 1 in the min term column. So this expression here 1 0 1, here it is 0 1 1, 0 1 0, 1 0 0. Okay, so mark 1 in the min terms column squares. That means 1 0 1 5, then 0 1 1 3, 0 1 0 2, 1 0 0 4. Next we can pair them. These two are adjacent, so we can pair these two. Here also this one is adjacent, so we can pair. Okay, when you pair these two ones, x is as such x bar, but here yz, here it is yz and here it is yz bar, 1 1 and 0, that means z is cancelled, then we get y. For this one we have x as such because 1, and here it is first variable 0, second variable 0 and 1, that is cancelled, that means z is cancelled and we get y only, xy. So our expression becomes f is equal to x bar y plus, so that is y bar, x y bar. Okay, here it is x, here it is 0, y is equal to 0 and z is 0 and 1, z is cancelled, and y is equal to 0 means y bar. So the expression is x bar y plus x y bar. Okay, one more thing to remember, that this left side column and the right side column are adjacent to each other. That means we can fold this like this. That means this column is adjacent to right side column. So suppose we have a 1 here, we can pair it as this one and this one. Okay, we can pair like this. Clear? Consider another example. F is equal to x bar yz plus xy bar z bar plus xyz plus xyz bar. Okay, here also there are 3 variables, 3 literals in each term. That means it is a 3 variable Boolean function. Next we can draw the K map. it has 8 squares representing the 8 minterms. So here we can write the variable x and here yz. So if x can have value 0, 0 and 1. So here it is 0, 0, 0, 1, 1, 1, 1, 0. Okay, so we can write the minterm. It represents the minterm 0. Represents the minterm 0, 1, 3, 2, 4, 5, 7, 6. So we can mark the minterms. Here it is the minterm as 0, 1, 1. Here it is 1, 0, 0, 1, 1, 1 and 1, 1, 0. That means 3 is equal to 1. Okay, minterm 3 is 1. Then 4 is 1, 7 is 1 and 1, 1, 0, 6 is 1. Okay, so how can we pair them? We can pair 3 and 7 together because they are adjacent. Then what about 4 and 6? 4 and 6 are also adjacent because here the leftmost column and the rightmost column are adjacent to each other. So we can pair like this. We can draw a open circle. Okay, so for this pair the Boolean expression is, here it is x can have value 0 and 1, so it is cancelled. Then yz is equal to xy, that means it is yz itself. Then for this pair, here it is 1 itself, x is 1, that means x itself. Then for yz, y is 0 and 1 and z is 0 only, so y is cancelled and we get z bar. So the expression, minimized expression, f is equal to yz plus x z dash. So this is the minimized Boolean expression. So you should remember that this leftmost column and the rightmost column are adjacent to each other. So we can pair this and this one. Okay, that's an important point. Another Boolean function, f is equal to a bar c plus a bar b plus a b bar c plus bc. Okay, so here it is not in a canonical form. Here one variable is missing, here also one variable is missing. Okay, here the missing variable is b. B is the missing variable, so b can have b and b complement. That means here we take it as a bar c into b plus b complement plus a bar b into missing variable is c, c plus c complement, then a b bar c plus, for the last term a is missing, so a plus a complement into bc. Okay, when you expand this, you get a bar b c, a b bar c plus a bar b c plus a bar b c bar plus a b bar c plus a b c plus a bar b c. Okay, so we can draw the K map. So here it is the separation. So here the variables are a and bc. A can have value 0, 1, bc can have value 0, 0, 0, 1, 1, 1, 1, 0. So our first one is a bar c. The missing variable is b. So we can take a bar bc. Okay, a bar bc 0, 1, 1, 3. Okay, next one is a bar b bar c 0, 0, 1. Okay, then a bar b missing is c, so a bar b c 0, 1, 1. Same as this one. Okay, we already marked. Then a bar b c bar, that means 0, 1, 0. Okay, next one is a b bar c 1, 0, 1. Next one is bc. BC we take a plus a bar, so ABC, that is 1 1 1, then a bar BC 0 1 1, that is we already marked. Okay, so next we can pair them. So here we have 4 ones adjacent to each other, so we can pair it, this 4 ones. Okay, then for this one it is paired with this adjacent one, so we have a one quad and a one pair. So for this quad, this A is cancelled, and for BC, B 0 or 1, so that is cancelled, then C only. So that means we have only C. Boolean expression is only C. So in this pair, A as such, that means A bar, then B is 1 and C is 1 and 0. So C is cancelled, B only, that means A bar B. So our Boolean expression F is equal to C plus A bar B. The minimized expression is C plus A bar B. So here we have a quad. So when 4 ones are grouped together, how many literals are cancelled? 2 literals are cancelled, and we get only 1 literal in the expression in the case of a 3 variable K-map. Right? When in the case of a pair, 1 variable is cancelled and we get a 2 literals in the expression. Right? Next, how grouping can be performed in the case of a 4 variable K-map. In the case of a 4 variable K-map, we have 16 minterms. So we can pair them, that means group of 2 members, or quad, group of 4 members, or octet, that means group of 8 members. Okay. So in the case of a 4 variable K-map, when you pair them, 1 variable is cancelled, so the expression contains only 3 literals. Okay, then when you pair 4 ones together, then 2 literals are cancelled, then we get only 2 literals in the expression. When 8 elements are grouped together, then 3 literals are cancelled and then we get only 1 literal in the expression. Okay, consider an example. F of W x y z is equal to sigma m of 0 1 2 4 5 6 8 9 12 13 14. So this is the given SOP form. So first we can draw the K-map. So K-map should contain 16 squares. Okay. So here it is the variables wx and here it is the variable yz. So yz can have values 0 0 0 1 1 1 1 0. Wx also have values 0 0 0 1 1 1 1 0. Okay. So this square represent the minterm 0. Here it is 1 3 2 4 5 6 7, and here it is 8 9 10 11 12 13 14 15. Okay, mark 1 in the given minterm columns squares, that means 0 1 2 4 5 6 8 9 12 13 14. Okay, so next is how can we group this ones. Here first we have a group of 8 ones. Here 8 ones are adjacent to each other, so first we group this 8 ones. Okay, next you remember that This left side column is adjacent to the right side column. Also the top row is adjacent to the bottom row. Okay, so here we have two ones. These two ones can be grouped with these two ones, form a quad. Similarly, these two ones can be grouped together with this ones, form a quad. So here we have three groups. Next we can write the Boolean expression for each group. Consider this octet. In the octet, this W and X are cancelled because W can have values 0 and 1, X also have values 0 and 1, so it is cancelled. Then Y is 0 and Z also 0 and 1, Z is cancelled. So we have only Y bar in the expression. Okay, then for this quad, W can have value only 0 but X is 0 and 1, so W is W bar, and here it is 0 0 1 0, that means Y is cancelled and Z only, that is Z bar. Okay, for this quad, W is cancelled and X only, that is X, and here it is 0 0 1 0, Y cancelled, Z only, that is Z bar. Okay, so we can write the Boolean expression as, minimized Boolean expression as Y bar plus W bar Z bar plus X Z bar. So this is the minimized Boolean expression for this Boolean function. Okay, then you should remember that map is considered as a surface with left and right edges, and also top and bottom edges are touching each other and forming adjacent squares. That's why we grouping this quads, two quads. Okay, so this is the procedure for minimizing a 2 variable, 3 variable and a 4 variable Boolean function in SOP form using K-map. This is very important topic, and we will use this minimization technique while designing digital circuits. So practice it with these questions. Okay, thanks for listening.